You might know that the attention has a U-curve. People usually concentrate more at the beginning and at the end of a session. So it is better to know that this is the last presentation of the day. So I hope that I can close this busy and really interesting day. My name is András Pinkasz. I am the second one on that list. This is a paper that is in work in progress. In the Hungarian Statistical Office, we are really curious about the effect of the automotive value chain, and you know that after the transition, many East Central European countries reintegrated into the global value chains, global automotive value chains, and this effect after the crisis became more intensive. So we realized many relocations of manufacturing activity from west to east. And I and my colleagues are interested in the degree of exposure on the automotive value chain, because we think that the classic data underestimate the effect. But it is not an easy project for us, so it is an experiment. What are we doing? So the first step that we did, but actually it is not the main part of our research. We wanted to see the macro data. We checked the relationship between automotive industry, so actually not automotive value chain, only the GVA, gross value added of automotive industry. So what is the relationship between the industry and the total GVA? And we found in many Eastern European or East Central European countries that there is a really strong connection between the two. But the problem of my office actually that global automotive value chain does not only consist of automotive industry. So there are many industries in that value chain, and that is a little bit stupid, but I hope interesting picture about schematic structure of GVC. You can see many actors, many transactions, but if you see the blue circles, for example, it can be an OEM, so original equipment manufacturer like Audi, Skoda, and so on. And you can see these green circles. It can be a tier 1, so the supplier of the OEM, like Bosch or Flextronics or Continental and so on. And you can see a small purple circle, or I don't know where can I, yeah. So for example there, this circle means local enterprise, a tier 2 enterprise who, yeah. And the main problem for us that if you see these blue circles, the OEM has several affiliates, for example. So an OEM, for example, Mercedes is an OEM, but Mercedes has many affiliates, for example, in India or in other countries where they operate a shared service center. So it is not obvious if you see a shared service center that is a part of a value chain. Or if you think that the green circles can be Bosch. Bosch is one of the biggest automotive supplier, but actually Bosch has several other equipments like this. So it is again not obvious what is the main product of Bosch. For sure they have several products. So we have to somehow simplify this story. and I want to show what is the main objective of our research, but we can simplify this like Eurogroup Register does this in the EU. We can isolate the MNEs, but in the story we miss many information about the connections, the transactions between the MNEs. Or we can make a classical GVC analysis, but it usually overemphasizes the role of the headquarters. And actually what we want to do with my colleagues to identify the main actors and the main transactions. And it is a little bit schematic, but the main result can be similar like this. So we can find, if we can identify the main actors, we can find some shared service centers, some local enterprises, some enterprises in the rubber industry or in the automotive industry, of course. But it is not so easy to identify these actors. So our project has two main objectives, actually, to make a good database and find a method, find a model that is good for analyze this database. And we are at the middle of this process, but we started to make a database. For sure, the main point of this database. So we want to identify the actors of the alternative value chain, and we try to more or less identify the connections between the actors. For example, what is their position in the value chain. So the starting point of us were the roles of the actors of the automotive industry, and after that we found, we looked for, we searched good database in the internet, who are the biggest OEMs, who are the biggest tier 1 companies, and we could use Eurogroup Register and foreign affiliate statistics to identify these companies' Hungarian affiliates. So that was a point where we could find many actors who are actually not in the automotive industry, but we have knowledge about their connection to the automotive industry, automotive value chain. And finally, what was really useful for us, we use VAT data that we got from the tax authority, and this database consists of many transactions between the actors. So we more or less know the main actors of the value chain. After that, we found these actors in the VAT database, and due to this database, we could make consequences about their position in the value chain, and we could find more actors in that value chain. So actually, now it is enough, I think, about the database. So and because we could see VAT data, we could get a picture about the transactions. We could see that, for example, a big tier 1, what is the ratio of the sales of the tier of for example, Bosch to a OEM? Yeah, so we could identify what a degree could an actor embedded into the automotive value chain. Yeah. And so we have a database that is, yeah, so we could use it, we could use this database, and after that we tried to find a method that we could use for further analysis, and we found a network model. It was based on Albert László Barabási's model. The first question of a network model, whether there is an order in the network or not. If there is no order in that network, it is called assertative, but if there is an order, we can call it disassertative. And the model that we used, it makes an analogy between, so the analogy is, so automotive industry, the analogy of the automotive industry is the spread of diseases, and we analyzed a potential spread of an economic shock in the automotive industry. So our assumption was that if the model that analyzed the spread of a disease, it can be useful for the analysis of the spread of an economic shock, and yes, so we used the model like this. And the original model used a probability as the infected individual. So the probability of our model is so the probability is determined in our model by the volume of the transaction with the GVC, with the automotive global value chain, and we could identify this number from the VAT database. So, and finally, we got a result like this. So this is the structure of the Hungarian automotive network according to our database. It is, so we are working on it, so I'm not sure that it will be the final structure of the automotive network, but yes, we see recently a network like this. And the main question for us, what will happen if an economic shock occurs, for example, a decrease of demand. And we used a model to estimate an economic shock. And we found that the spread of an economic shock, because of, we think, the just-in-time system, it is really fast. But as I mentioned, it is a work in progress model, so we only analyze the relationship at that point between the OEMs and Tier 1s, but we want to extend our project to Tier 2 and Tier 3 companies. And yes, I finished the presentation. Thanks, and yes, if you have any question, I try to answer it.
Good, thank you very much. On this one occasion, we actually do not have a discussant. The person has not been able to come today. So can I invite questions from the floor? Yes, please.
Very interesting, very good work for this problem, which is very difficult to make this network analysis. One way you can distinguish also between domestic and foreign corruption, because the discussion in this kind of GVCs is always who is the owner and who is basically taking decisions. Because if you say there's an economic shock, and I don't know exactly Hungary, but Slovak Republic, it would be Volkswagen who, in Stuttgart, who is doing basically the decision what happens then in Slovak Republic. So you can differentiate that as well in your...
Yes, and that is the constraint of the GVC models, I think, because usually they care only about the local enterprises. How can a local enterprise upgrade? What is the situation of typical Slovakian or Czech enterprise in a crisis? But, and for sure it is really important because these are the companies who maybe leave the profit in the country. But if we want to analyze the employment, in this case, that is really important to make more attention to the foreign companies' affiliates. So we want to integrate the two in a mutual model, but actually that will be a really main point to identify the role of the Hungarian actors of the GVC. So actually we want to understand the whole consequence of an economic shock, and we want to divide the effects, what is the effect on the Hungarian companies and what is the effect on the foreign affiliates.
What is the share of investor automotive in GDP of Hungary?
It is hard to answer because of this GVC story. So actually, in the GVA or in the GDP, the share is maybe 6 or 7%. But you know, rubber industry, electricity. So I think the share of it is much more. There are many chemical companies. For example, I talked with my friend who works in a big chemical company, and I realized that they produce some chemical stuff to China, and it will be one of the main part of a car. So actually, there are many effects that we couldn't realize. So it is, if our project will be successful, I think so our method, I think, could work, but for example, but I think we can't identify all the main actors. But if we can extend the actors to other if we can extend the automotive value chain, yeah, we can make a better estimate. I hope so.